Question 52. 50 cm cube of carbon 2 oxide was exploded with 150 cm cube of air containing 20% oxygen in volume. Which of the reactants was in excess? A. Carbon 2 oxide. B. Oxygen. C. Carbon 4 oxide. D. Nitrogen. Solution. Volume of carbon 2 oxide is equal to 50 cm cube. Volume of oxygen is equal to 20% of 150 cm cube of air. That is 20 over 100 times 150 over 1, which is 30 cm cube. From the equation, 2 moles of carbon 2 oxide plus 1 mole of oxygen to give 2 moles of carbon 4 oxide. From ratio of reacting volume is 2:1:2. Volume mixed is 50:30, where carbon 4 is not known. Volume used up is 50:25:50. Volume in excess is 50 over 50, which is 0. 5 cm, that is 55 cm cube. Therefore, 5 cm cube of oxygen was in excess. Answer is B. Question 53. The ratio of the initial to the final pressure of a given mass of gas is 1:1.5. Calculate the final volume of the gas if the initial volume was 300 cm cube at the same temperature. A. 750 cm cube. B. 450 cm cube. C. 200 cm cube. D. 120 cm cube. Solution. The ratio of initial pressure to final pressure is 1:1.5. Whereas the initial volume of the gas is equal to 300 cm cube. But from Boyle's law, P1V1 is equal to P2V2. That is, 1 times 300 is equal to 1.5 times V. Therefore, V, making V the subject of the formula, we have 1 times 300 all over 1.5, which will give us 200 cm cube. Therefore, the answer is C. Question 54. Sieving is a technique used to separate mixtures containing solid particles of A. Small sizes. B. Large sizes. C. The same size. D. Different sizes. Solution. A sieve is a device consisting of identical openings of specific dimension through which particles of solid pass out. Finer particles may pass through, whereas large particles will not pass through. Thus, particles of different sizes can be separated. Therefore, the answer is D. Question 55. The partial pressure of oxygen in a sample of air is 452 mm mercury, and the total pressure is 780 mm mercury. What is the mole fraction of oxygen? A. 5.790. B. 2.030. C. 0.579. D. 0.203. Solution. The partial pressure of oxygen in air is equal to 452 mm of mercury. Total pressure is equal to 780 mm mercury. At 760 mm mercury, 22.4 dm of gas oxygen contain 1 mole of gas. Therefore, 452 mm of mercury will be equivalent to 1 over 760 times 452 over 1, which gives us 0.5947, which equals to 0.59 mole of oxygen. Also, if 760 mm of mercury is equivalent to 1 mole of gas. Therefore, 780 mm of mercury is equals to 1 over 760 times 780 over 1, which will give us 1.026 mole. Therefore, total number of moles is equals to 1.026. But mole fraction is equals to number of moles of a gas over total number of molecules. That is 0.594 over 1.026, which will give us 0.59. Therefore, the answer is C. Question 56. Which of the following compound is composed of aluminium, silicon, oxygen, and hydrogen? A. Clay. B. Limestone. C. Epsom salts. D. Urea. Solution. Aluminum ore includes the oxides of aluminum. Example: bauxite, Al2O3H2O. Fluorides. Examples: cryolites, in bracket Na3AlF6. Clay. Example: kaolin, in bracket Al2Si2OH2O. And mica with chemical formula K2Al2Si6O15H2O. Therefore, the answer is A. Question 57. A mixture of iodine and sulfur crystals can be separated by treatment with A. Water to filter off sulfur. B. Methanol to filter off iodine. C. Ethanoic acid to filter off sulfur. D. Carbon 4 sulfide to filter off iodine. Solution. Sulfur is soluble in carbon 4 sulfide with chemical formula CS2, whereas iodine is not. Therefore, on addition of CS2 to the mixture, sulfur dissolves, leaving iodine crystals, which are treated off. Answer is D. Question 58. How many moles of hydrochloric HCl will be required to react with potassium heptaoxodichromate 7 to produce 3 moles of chlorine? A. 14. B. 12. C. 11. D. 10. Solution. From the equation, potassium heptaoxodichromate 7 reacts with 14 molecules of hydrochloric acid to give 2Cl plus 2CrOCl3 plus 3Cl2 plus 14H2O. 14 molecules of HCl react with 1 mole of potassium heptaoxodichromate 7 to liberate 3 moles of chlorine, that is HCl2. Therefore, the answer is A. Question 59. The distance between the nuclei of chlorine atom in chlorine molecule is 0.194 nanometers. The atomic radius of chlorine molecule is A. 2.388 nanometer, B. 0.388 nanometer, C. 0.194 nanometer, D. 0.097 nanometer. Solution. Atomic radius is the distance from the nucleus of an atom to the outermost electron shell of the atom. If the distance between the two nuclei of chlorine atoms in the molecule is 0.194 nanometer, A, B, or B, A, B, the atomic radius is equivalent to 0.195 over 2, which is equal to 0.097 nanometer.